thank you for stepping up and coming on stage. So you are going to introduce this tool. So you are CTO at 𝘂𝘁𝗂𝗂𝗂𝗂. It's a spin-off company, a startup that was created after the conference. And so I'll let you present.
Thanks a lot. So I will not go in deeper into what's DQM-ML do, because it has already been present on a previous meeting, and so you also have a documentation. What we will focus on is some definition which explain how it works inside, how we can extend it, what are the evolutions that we performed during Q4 2025, and then how such tools can be used to compute metrics on such use case as well as welding that has been presented before. And we will also discuss about limitation and future developments. If I go to definition, it's because this is definition that are shared between all our metrics, and it's a way to make all metrics more standard and with the way we interact with data. So we'll discuss about sample, which is one of the sample in your data set that you are using. And it's a list of features. It's a list of elements, metadata or training features. This feature can be raw. For example, it can be an image, it can be information, it can be compute from other features, such as validity bytes, such as quantized representation, such as latent space. And it's usually inside the data set, a column or something that can be compute from columns. Data selection is a selection of several samples that are grouped together because of a specific behavior, context, or evaluation you want to perform. Then you have metrics. When we discuss about metrics, it's something that we compute on a group of samples, here's data selection, with different scope. So we have metrics that are on one feature only, a metrics that take in all the samples. And we also have metrics that are inherent to the groups, or metrics that are relative. So which represent something like a distance between two data selection. And so this will be important to understand next. And then we introduce the concept of batch. Why we are discussing about batch is because for computation efficiency, we need some time to compute only partial elements between inside a selection, and then aggregate all these elements. And then that's what we call batch metrics under. It's a way to have intermediate computation that we can keep in memory in order to have an efficient implementation of the metrics. I put it here on this scheme. So you have data set. It's a very basic one here. You have several columns with numerical, textual, or floating point features. You split them in batch so that we can compute one batch at a time for the whole data you have inside your features. Then you need to compute intermediate values or maybe something feature that you do not want to store because they are only temporary ones. And then based on these features, you want to compute batch metrics. And then based on these batch metrics, you are able to compute the final metrics of the data selection we are working on. Doing so, we were able to implement an improvement, or a set of improvements on DQM-ML. It was a side evolution of the original DQM-ML, because we do not want to cut compatibility without providing the proposal to the community. So it's just you can use both implementation currently, the old one and the new one, and we just stick to provide the same functionality as the previous one. So there's no change inside the different metrics, just a standardized interface and a way to compute bigger metrics on bigger data set and to make them easier to use. So we focus on 3 dimensions. First, scalability. So because the previous implementation need to put all the data set in memory, which was not possible with big data sets. Second is interoperability. So we try to provide an interface that will be able to communicate with different kind of library, tools, etc., and to have all metrics sharing the same pattern. And the last one was dependency, which is not currently available on the DQML, but can be used if we use all the sub-package DQML star, because as several metrics can need some specific tools and library, we do not want to have a all-in-one package that trigger all the dependency. So when you install your DQM-ML, you can select which sub-metrics you want, and you will just have the needed dependency for your installation. So this is the three main focus we work on for the last quarter. So here you have a basic API, which is we compute feature, something that was not present inside the previous DQM-ML. So you have to build your features before calling DQM-ML. But for some feature, for example, for image blur, brightness, etc., you want to have the ability to do it in the same time as you compute metrics on data selection. Second was to be able to compute batch metrics. It's optional, so depending on the metrics, if you are not able to create intermediate representation per batch, it's not mandatory to use them. Then you have the compute, which take into account all the output of batch metrics or compute features to really build the desired metrics for the selection you build. And there's also a compute delta for metrics which are compared to data selection. So based on this, we build benchmark, which check that the new implementation provides same kind of answer the previous one, so that we do not generate regression, and also that the performance at least are the same or are improved, because it was not the objective was not to provide an optimization of the library, but mainly to be able to tackle bigger data sets. But even if it was not what we intended to do, we have some improvement of performance on some metrics. So here you have the basic metrics which were performed on 2 million rows, 4 columns, and without batch here. And we do the same to compare with batch. So we use batch of thousands of rows in this case. So you will have the slide. I do not want to comment all the line. Then we have the domain gap. I don't understand. There's some change in format, but by the way, so domain gap is where we compare two data selection. In this case, we have several metrics which depend on inference of models, and so that's why all the DQML, the domain gap metrics has been put in a separate package. So if you do not need these metrics, you do not have to integrate a different dependency to PyTorch and models. Next one, how to use it. You have two ways to use it. The first one is as previous. You can import the different metrics, directly use them with a Parquet file if you have Parquet file, and it's take this as a default format. But you can also convert them from Panda data frame. So this is the recommended way to test the metrics. But if you want to generate integrated process inside your MLOps, you also have a way to invoke all the metric computation based on a configuration file where you put where are your input data selection, which kind of metrics you want to compute on them, and then where you want to output the metrics. So it's very user-friendly to integrate inside your MLOps environments. Then once we have that's the evolution we have performed, and we apply them on the data from the data well-dig challenge. So I will not going deeper in fact because I would have no time. But in the DQML, we as you see before, I will not explain why, but we have to generate a lot of different data sets with different characteristics. And okay, it's great, we create them, but how we understand what is inside your data. And even if you specify what you want to monitor and understand maybe the metrics you have inside your data. And I will not go into detail on all the metrics we can generate. There's a lot of them, but I will emphasize here on several of them. Here you have all the data sets, and we can compute diversity estimation on all these data sets for different columns. Here we compute it for blur, for contrast, for luminosity, and it helps us to identify some particular behavior. For example, here you can see that generation eval dataset has a very low diversity of luminosity. And this is something that is understandable, as we take for generation datasets data which were taken 2 years after the first one, after the training one. So 2 years where they tackle the problem of luminosity inside the environment. And so luminosity was far more better control in the last deployed solution, but in the early one. So it's something that we can see with such a matrix. So it's something to compute and maybe to monitor, and inside your process, I will not enter it, you have something to control. Other metrics can be, for example, representativeness. Here you have a single digit which give you an overview of representativeness regarding different metrics. For example, here it's GRT we use to compare the entropy of different dimensions of your data set. And it's easier to have a single digit to identify the kind of distribution you have behind. So, for example, here you have low representative, you have several split, and maybe not a lot of data in several parts of your dimension, and you have a high representativeness dimension on below. So, being able to generate for all your different data sections, the different way you select data, a single matrix which help you to understand, maybe detect some specific pattern in specific data selection, and to monitor them during time, because you can have drift, but you want to monitor such a matrix on your data set in operation. Here, for example, to see that it can highlight some behavior that was expected or unexpected inside your model, you have here the domain gap that was computed between different data sets. So the standard evaluation data set, and for example, you have a drift evaluation data set. As you can see that the drift evaluation data set is really bigger in terms of distance that the other, and it's the expected thing that we want, because we want to have some drift evaluation that are far from the evaluation data set to see how the models or the component behave for such drift. And so this is, we build it and we can verify that we have what we want. But okay, I do it on a data set level, but data selection can not only be the data set, it can also be classes, it can be also any other kind of context you want to analyze inside your data and compare between your contexts. For example, here we do it on the different class of welding, and it shows us some similarity between different kind of weld, which are similar, and so the distance between the two data sets are smaller than between the others. So if I sum up what we have done, is we have proposed a more standardized API to implement metrics. It's also provide a framework where new metrics can be implemented as independent package. So if new metrics want to be implemented, it's easy to integrate them inside the DQM-ML process and to take advantage of all the script and configuration. The next step will be to transfer documentation for the legacy one to the new implementation. And we also, as we have integrated feature for images, we will likely to integrate features for time series, so to have a more complete metric computation elements, and also to import and support different other data format, input, output, etc. But it will be done part inside the interoperability works after this implementation. So maybe
So, Loic, you want to check if we have a question?
Maybe if there's a question, I just let me check.
Yeah, I don't think we have any questions on the chat. I've been looking into that.
So please feel free to contact us if you have any question. I do not focus on the scientific part, which has already been present, but more on how we put it to an industrial usage of what has been implemented before.
Perfect. Thank you very much, Loic, for the presentation of DQM, and as you invited. So if there is any question, we will share with you.